Welcome friends to my YouTube channel. Now on last lecture I have introduced the concept of collision and there I told the various type of collisions, okay, and elastic, inelastic and perfectly inelastic, okay. Now in today's lecture I shall going to discuss the direct collision process. First of all we discuss Newton's rule of collision. First of all, we discuss this Newton's collision rule. Okay. So what is it? Suppose there are two objects. This is one. This is one. Say this is of mass m1 and this is mass m2. This object moves in this direction and this object moves in this direction. That means both the objects are approaching towards. Okay. So both the objects are approaching towards. Okay. So if initial velocity of m1 before collision is u1 and that of m2 is u2, and after v1 and v2, after collision they attain the velocity v1 and v2. That means after collision these particles can move in opposite direction. That is, if before m1 moves along this direction, after collision m1 moves in the opposite direction, and if before collision m2 moves along this direction, after collision m2 move along this direction. Okay. So what will be the velocity of approach before collision? Velocity of approach before collision is simply u1 minus u2, provided here we assume that u1 is greater than u2. Okay. So this is the velocity of approach before collision. So after collision both the particles move in the opposite direction. So what will be the velocity of separation after collision? Velocity of separation after collision, this is simply v2 minus v1. So Newton's collision rule states that the ratio of velocity of separation and to the velocity of approach, this is equal to a constant that is called coefficient of restitution. Okay. So that is the velocity of separation divided by velocity of approach. This must be equal to a constant. That means velocity of separation is proportional to velocity of approach. So this is called restitution coefficient. Restitution coefficient, and the value of E determines the nature of the collision. Okay. So value of E determines the nature of the collision. So just we take a simple example so that the concept will be clear. Okay. Now we have write E as v2 minus v1 by u1 minus u2. So if the collision is perfectly elastic, then we can write E as 1. That means v2 minus v1, this equals to u1 minus u2. If E is 1, this is known as perfectly elastic, and if E is 0, that is perfectly inelastic collision. What happens? Perfectly inelastic. E is 0 means v2 minus v1 equals to 0. That means v2 equals to v1. that I told yesterday, that for a perfectly inelastic collision, both the bodies combine, stick together and move with a common velocity. That means both the bodies have same velocity after collision. So this is the result. Both the velocities will have a common velocity. Say this is v, no problem. Okay. So this is the result, that after perfectly inelastic collision, the bodies stick or combine together and move in a particular direction with a common velocity. Okay. This. Now let us discuss the direct collision process at first. Okay. Direct collision process. Okay. So suppose this is, there are two objects m1 and m2. This moves in this direction and this moves in opposite direction. So if u1 and u2 are the velocity before collision, okay, and say after collision they move in opposite direction, so m1 can move in this direction and m2 will move along this direction. Okay. So after collision their velocities are v1 and v2. Okay. So here the law of conservation of linear momentum hold good. That means before collision this is the linear momentum of the system, and after collision this is the linear momentum of the system. So we can write m1 u1 minus v1, this equals to m2 v2 minus u2. Okay. So this gives the equation number 1, because whether the collision is elastic or non-elastic, law of conservation of linear momentum always holds good. That's why we use it. Now if we take perfectly elastic collision, okay, so the energy conservation also holds good. That is this m2 u2 square, this equals to half m1 v1 square, half m2 v2 square for elastic collision. Okay. So half cancels all, so we can write m1 into u1 square minus v1 square, this equals to m2 into v2 square minus u2 square. This gives a name, say 2. Now what happens if we divide these two? Okay. So if we divide these two, then what happens? We get u1 plus v1, this equals to v2 plus u2. Okay. So after dividing we get this. So from which we can write v2 as u1 plus v1 minus u2. Now if we substitute this value of v2 in previous equation, so previous equation means the law of conservation of linear momentum equation. So what we get? That equation is this. Now if we substitute the value of v2 here, so what we get? u1 plus v1 minus u2, that means minus 2u2. So this is simply m1 v1 minus m1 u1 minus m1 v1, this simply m2 u1 plus m2 v1 minus 2u2 m2. Okay. So if we take v1 common, then simply m1 plus m2, this equals to 2u2 m2 plus m1 u1 minus m2 u1. So we can write v1 as 2u2 m2 by m1 plus m2 plus u1 into m1 minus m2 by m1 plus m2. So this is the expression of velocity after collision for the particle of mass m1. So what we did, simply we apply the law of conservation of linear momentum and energy conservation by assuming that the collision is elastic. So after dividing these two equations we get this. So if we find the value of v2 and put this value of v2 in previous equation, we find v1. Now similarly, if we, what is the value of v1 from this equation? This is simply v2 plus u2 minus u1. If we substitute the value of v1 in this equation, then we can find the value of v2. So let's do it. Okay, so m1 into u1 minus v1, m2 into v2 minus u2. Now we have to put the value of v1, that means u1 minus v2 minus u2 plus u1. This equals to m2 v2 minus m2 u2. Now m1 u1 minus m1 v2, there will be 2 m1 u1 minus m1 u2. This equals to m2 v2 minus m2 u2. So if we take v2 common, this simply m1 plus m2. This equals to 2 m1 u1 plus m2 u2 minus m1 v2. So what will be my v2? My v2 will be 2 m1 u1 by m1 plus m2 plus minus m1 u2 plus m2 u2. This will be m2 u2. I made a mistake. It will be m2 u2. So m2, this is simply u2 minus u1 by m1 plus m2. So these are the values of v1 and v2 after collision. Okay, so simply by from this equation at we find v1 and then putting in this equation we get v2. Similarly, from this equation by finding the value of v2, and if we put this equation we will get v1. Okay, so we have find out the value of both the velocities before collision. Okay, so simply we get this 2u2 m2 by m1 plus m2 plus u1 m1 minus m2 by m1 plus m2. Okay, and what will be my v2? That is 2 m1 u1 by m1 plus m2 plus m2 common nile u2 minus u1 by m1 plus m2. So these are the velocities before collision. Okay, now we shall simply discuss here one special case today, that what happens if both the objects are of same mass. Okay, what happens if both the objects are of same mass. Say this is m. So what happens if both the objects are of same mass? So this term is 0. Okay, so 2u2m by 2m u2, and what will be v2? This term is 0, that is 2m u1 by 2m, that is u1. Okay, so if we can consider that the both mass objects are of same mass, then these terms are 0 because m1 equal to m2, and if we put m1 equal to m2 equal to m, so we see v1 equals to u2 and v2 equals to u1. So objects of same mass will interchange their velocity. Okay, so objects of same mass can interchange their velocity after collision. Okay, so in today's lecture we shall discuss about Newton's collision rule and the direct impact between the two bodies, and we have found the velocity after collision, and we take a special case that both the objects are of same mass. So in my next lecture I shall going to discuss few other special cases related to this equation. Okay, so if you don't subscribe my channel, then kindly subscribe it and like it and share it. Okay, and also you can write comment in comment section. Okay, thank you.